Every morning, you wake up to choices. Some are monumental. To accept an opportunity, to confess a truth, to end a relationship, to take a leap into the unknown. Others are trivial. Which shirt to wear, which path to walk, whether to pour one more cup of coffee. Most of the time, these decisions blur into routine, swallowed by the forward motion of daily life. But what if every single one of those choices, the grand, the subtle, the almost invisible, was not swallowed, not erased, but instead set the universe itself trembling? What if the moment you decided yes or no, reality itself forked, splitting into two paths, one where you made one choice, and another where you made the opposite? What if the universe, at its deepest level, is not a single story, but an infinite branching of possibilities, each new line woven by the tiniest of your decisions? Imagine holding a cup of coffee in your hand. A single slip spilling it, staining your shirt, might make you late for work. Being late means missing the train. Missing the train means not meeting the stranger who might have changed your life. In the world you know, the coffee stayed in the cup. But in another, it spilled. And from that one slip, an entire alternate history unfolds, echoing forward in directions you'll never see. To most of us, this sounds like science fiction, a fun idea for novels, movies, or late-night speculation with friends. Yet, for some of the greatest minds in physics, this is not fiction at all. It is a serious possibility born from the strange rules that govern the quantum world. And if those rules apply universally, then every decision, every moment, may split reality in two. Consider the strange duality of existence itself. On the surface, our lives feel linear, past behind us, future ahead, each choice closing doors behind us while opening new ones in front. But beneath that surface, physics tells us a different story, one where particles can exist in multiple states at once, where outcomes aren't fixed until observed, and where the universe itself may be far less singular than we imagine. This is the paradox that sits at the heart of the multiverse hypothesis. To some, it is an elegant answer to the mysteries of quantum mechanics. To others, it is an absurd leap, unprovable and almost mystical. But regardless of where the truth lies, the idea itself changes everything about how we see our place in the cosmos. Take a moment to picture the sheer scope of it. Every decision you make, whether to turn left or right, to speak or remain silent, creates another universe where the opposite decision unfolded. Somewhere there is a version of you who didn't quit that job, who said yes to that invitation, who chased the dream you let slip away. And somewhere else, another version who made choices you cannot imagine. This is both thrilling and unsettling. On one hand, it suggests infinite possibilities, infinite second chances, infinite worlds where the paths not taken still stretch forward. On the other hand, it confronts us with the thought that we may not be as singular, as unique, as we believe. If countless versions of you exist, does the you sitting here now matter any less? Or perhaps matter even more? This tension between freedom and fate, between singularity and infinity, has haunted human thought for centuries. We have asked whether our choices are our own, or if the future is already written. Now, physics tempts us with an even stranger suggestion, that every choice is both written and unwritten, both chosen and unchosen, simultaneously real in a tapestry of universes sprawling beyond comprehension. Some will resist this idea immediately. They'll say, "Show me the evidence. Prove to me that another me exists somewhere out there." And in truth, proof remains elusive. The many worlds interpretation of quantum mechanics is controversial, debated fiercely among scientists. There are those who see it as a natural consequence of mathematics, and those who dismiss it as philosophy in disguise. But pause for a moment. Imagine being alive 500 years ago, before telescopes revealed the true scale of the cosmos. Back then, the idea of countless stars, countless worlds, was dismissed as wild fantasy. Today, we know that the universe is filled with billions of galaxies, each holding billions of suns, each sun orbited by countless worlds. Perhaps the many worlds theory is equally audacious. Perhaps in time, it too may become a truth too vast to deny. The hook of this story lies not only in its science, but in its implications for the human spirit. If the universe splits with each decision, then every moment is charged with cosmic weight. Your smallest actions ripple across infinity. And yet, paradoxically, it also means that every version of you, every success, and every failure exists somewhere. Does that free you from regret or burden you with it? Does it empower you or render you insignificant? The answer may not be clear, but the question itself changes the way we live. Because to wonder if each choice splits the universe is to feel the gravity of being alive. To walk through your day aware that reality may be branching around you, endlessly, in silence, in mystery, in possibility. This documentary begins with that mystery. We will journey from the hard mathematics of quantum mechanics to the speculative horizons of multiverse theory, from the myths of ancient civilizations to the philosophical depths of consciousness itself. Along the way, we will confront skeptics, dreamers, and visionaries. And at every turn, we will return to the same haunting thought. What if the simple act of choosing is enough to create a new universe? The choice to stay or to leave. The choice to speak or to remain silent. The choice to imagine or not to imagine. Each one a potential fracture in reality. Each one an echo in eternity. And so, as we begin this journey into the quantum mysteries of existence, consider this moment. You chose to watch, to listen, to wonder. Somewhere else, another you has turned away. But here, now, in this version of reality, you are with us. And that choice may be the beginning of a story far larger than you ever imagined. To understand why some physicists believe every choice could split reality in two, we have to descend into the strange foundations of the universe itself. Quantum mechanics. Every morning, you wake up to choices. Some are monumental. To accept an opportunity, to confess a truth, to end a relationship, to take a leap into the unknown. Others are trivial. Which shirt to wear, which path to walk, whether to pour one more cup of coffee. Most of the time, these decisions blur into routine, swallowed by the forward motion of daily life. But what if every single one of those choices, the grand, the subtle, the almost invisible, was not swallowed, not erased, but instead set the universe itself trembling? What if the moment you decided yes or no, reality itself forked, splitting into two paths, one where you made one choice, and another where you made the opposite? What if the universe, at its deepest level, is not a single story, but an infinite branching of possibilities, each new line woven by the tiniest of your decisions? Imagine holding a cup of coffee in your hand. A single slip spilling it, staining your shirt, might make you late for work. Being late means missing the train. Missing the train means not meeting the stranger who might have changed your life. In the world you know, the coffee stayed in the cup. But in another, it spilled. And from that one slip, an entire alternate history unfolds, echoing forward in directions you'll never see. To most of us, this sounds like science fiction. A fun idea for novels, movies, or late-night speculation with friends. Yet, for some of the greatest minds in physics, this is not fiction at all. It is a serious possibility born from the strange rules that govern the quantum world. And if those rules apply universally, then every decision, every moment, may split reality in two. Consider the strange duality of existence itself. On the surface, our lives feel linear, past behind us, future ahead. each choice closing doors behind us while opening new ones in front. But beneath that surface, physics tells us a different story, one where particles can exist in multiple states at once, where outcomes aren't fixed until observed, and where the universe itself may be far less singular than we imagine. This is the paradox that sits at the heart of the multiverse hypothesis. To some, it is an elegant answer to the mysteries of quantum mechanics. To others, it is an absurd leap, unprovable and almost mystical. But regardless of where the truth lies, the idea itself changes everything about how we see our place in the cosmos. Take a moment to picture the sheer scope of it. Every decision you make, whether to turn left or right, to speak or remain silent, creates another universe where the opposite decision unfolded. Somewhere there is a version of you who didn't quit that job, who said yes to that invitation, who chased the dream you let slip away. And somewhere else, another version who made choices you cannot imagine. This is both thrilling and unsettling. On one hand, it suggests infinite possibilities, infinite second chances, infinite worlds where the paths not taken still stretch forward. On the other hand, it confronts us with the thought that we may not be as singular, as unique, as we believe. If countless versions of you exist, does the you sitting here, now, matter any less? Or perhaps, matter even more? Einstein himself was deeply unsettled. God does not play dice with the universe, he famously remarked, rejecting the idea that randomness lay at the heart of reality. For him, quantum mechanics had to be incomplete, a temporary framework awaiting a deeper, hidden order. Niels Bohr, on the other hand, embraced the strangeness, insisting that probability and uncertainty were not flaws but fundamental truths. Their debates raged for decades, crystallizing a tension that has never been fully resolved. Is the universe truly indeterminate, or do unseen variables guide its outcomes? This clash between determinism and indeterminacy became one of the defining dramas of modern science. On one side stood centuries of faith in predictability. On the other, the unsettling discovery that, at the deepest level, reality is not fixed until it is observed. For ordinary life, the strangeness seems distant. We don't see cats in two places at once, or coins hovering as both heads and tails. Yet quantum mechanics insists that at the level of atoms and particles, this is exactly what happens. Schrödinger dramatized the paradox with his famous thought experiment, a cat sealed in a box, its fate tied to a quantum event. Until observed, the mathematics implies the cat is both alive and dead, a superposition of contradictory states. Only when the box is opened does the cat resolve into one outcome or the other. But why? Why should observation hold such power? Is it the act of a conscious mind that collapses the wave function? Or is measurement simply an interaction with the environment? Does the universe wait for awareness, or is awareness simply another kind of physical process? These questions haunt the very foundations of physics, pushing us toward the frontier where science and philosophy blur. Some interpretations, like the Copenhagen view, accept collapse as a brute fact. The wave function represents probabilities until observed, and that's the end of the story. Others, like the pilot wave theory, argue that hidden variables guide particles beneath the surface, restoring determinism. Still others seek to eliminate collapse entirely, proposing that the wave function never collapses at all, that every possible outcome occurs, each in its own branch of the universe. Here lies the seed of the many worlds interpretation. Instead of asking why one outcome happens instead of another, it dares to say, both happen. When the electron passes through the slits, it doesn't choose left or right. It goes both ways in separate realities. When the cat's life hangs on a quantum event, both the living cat and the dead cat exist, each in its own world. To skeptics, this sounds absurd, multiplying universes without evidence. To supporters, it is elegant, removing the arbitrary rule of collapse and letting the mathematics speak for itself. Either way, the idea grows directly from the strange soil of quantum mechanics, rooted in the experiments that revealed the uncertainty at the heart of existence. And so we arrive at a profound crossroads. Classical determinism promised a predictable cosmos, but quantum mechanics confronts us with indeterminacy and possibility. Is reality a single thread, tightly woven, or an endless fabric unraveling into countless strands? Are we witnesses collapsing probabilities in the facts, or wanderers drifting through infinite branches of possibility? The truth is, no one knows. The mathematics works. The predictions are astonishingly accurate. Quantum mechanics governs the microchips in our devices, the lasers in our communication networks, the fusion burning in the hearts of stars. And yet, beneath its success lies a riddle. What is reality made of? Probability or certainty? Unity or multiplicity? This is the question that leads us deeper into the mystery. If the wave function never collapses, if every possibility unfolds, then each decision may be more than a personal choice. It may be a fracture in the very fabric of existence. From the double-slit experiment to the paradox of Schrodinger's cat, the evidence points us toward a universe stranger than we ever imagined. And it is from this foundation, from the shimmering uncertainty of the quantum world, that the idea of many worlds emerges. A vision where nothing is lost, where every path is taken, where reality is not one but infinite dot as we leave the realm of experiments and equations behind. We carry with us the haunting question: when you choose, when you observe, when you simply exist in this moment, what is happening beneath the surface of reality? Is the universe collapsing into one outcome or branching into many? The answer awaits in the next step of our journey. The birth of the many worlds interpretation. By the mid-20th century, physics had transformed our understanding of reality. The quantum revolution had shown that particles could exist in multiple states. That observation played a mysterious role in collapsing possibilities into facts, and that the universe itself seemed to operate on rules beyond human intuition. But for all its mathematical success, the question lingered like an open wound. What actually happens when a quantum event resolves into one outcome? Most physicists, following the Copenhagen interpretation championed by Niels Bohr and Werner Heisenberg, accepted a pragmatic answer. The wave function, the mathematical cloud of possibilities, was not real in itself, they argued, but merely a tool for predicting outcomes. When an observation occurred, the wave function collapsed into a definite state. This collapse wasn't explained. It was simply asserted. For many, this was enough. The equations worked, experiments matched predictions, and technology thrived on the strange rules of the quantum world. But not everyone was satisfied. To some, the Copenhagen interpretation felt like a patch, a story told to cover up a deeper ignorance. Why should the act of measurement hold such cosmic power? Why should nature care whether a particle was observed or not? The collapse seemed arbitrary, unscientific, a rule inserted not because it was elegant, but because it was convenient. In 1957, a young graduate student named Hugh Everett III offered a radical alternative. Instead of collapse, he proposed, why not take the wave function seriously? What if the mathematics describes reality exactly as it is, an evolving superposition of all possible states? If so, then the wave function never collapses. Instead, every possibility contained within it is realized. When a quantum event occurs, the universe itself branches, splitting into multiple versions where each outcome takes place. Imagine tossing a coin. In Copenhagen, the universe chooses. Heads or tails, one outcome made real, the other erased. But in Everett's vision, no choice is erased. Both outcomes happen. One universe sees heads, another sees tails. The wave function does not collapse. It unfolds continuously, into an ever-branching tree of realities. Everett called this framework the relative state formulation. Later, it would become famous as the many worlds interpretation. Its implications were staggering. No longer was quantum mechanics about probabilities that resolved into singular outcomes. Instead, every probability was realized somewhere. The randomness of the universe dissolved into determinism, not because only one thing happened, but because everything happened at first glance. This vision is breathtaking. It eliminates the mystery of collapse. It restores mathematical consistency. And it explains the interference patterns of quantum experiments with elegant simplicity. But it also demands a price: the acceptance of countless parallel universes, each as real as the one you inhabit, each branching from every quantum event in the fabric of reality. For Everett, this was not science fiction. It was the logical consequence of taking the equations seriously. Yet for his peers, it was too much. The idea of universes splitting with every quantum event seemed absurd, untestable, and extravagant. Why multiply worlds without necessity? Why abandon the comfort of collapse for a vision that bordered on metaphysics? The reception to Everett's work was cold. His PhD advisor, John Wheeler, initially supported him, but after Everett presented his thesis, the wider community largely dismissed it. Niels Bohr himself, the towering authority of quantum theory, found the proposal unnecessary and even offensive to the pragmatic spirit of physics. In a world where the Copenhagen interpretation reigned supreme, Everett was seen not as a visionary, but as a heretic. Disillusioned, Everett left academia soon after completing his doctorate. He moved into military and industrial research, applying his mathematical brilliance to practical problems. But he never again returned to the front lines of physics. His great idea, published but ignored, drifted into obscurity. By the time he died in 1982, at just 51 years old, the many worlds interpretation was little more than a footnote in the history of quantum theory. And yet, ideas have a way of resurfacing. In the decades after Everett's death, a new generation of physicists began to revisit his proposal. As quantum mechanics matured, the problem of measurement remained as unsolved as ever. The collapse postulate still seemed arbitrary, even unscientific. Everett's vision, once dismissed as extravagant, began to look like a path toward coherence. Gradually, the tide shifted. Physicists like Bryce DeWitt popularized Everett's ideas, coining the phrase many worlds and framing the interpretation as a serious alternative. Quantum cosmology studying the universe as a whole made collapse even harder to justify, since there was no external observer to trigger it. In this context, Everett's branching universes began to seem less like fantasy and more like necessity. Today, the many worlds interpretation remains controversial. Some physicists embrace it for its mathematical clarity, arguing that it solves the measurement problem without ad hoc rules. Others reject it as untestable, a story that multiplies realities without evidence. The debate remains fierce. Is Everett's vision the future of physics, or a philosophical detour dressed in scientific language? What cannot be denied is the audacity of his idea. In a world where most accepted collapse as an unsolved but tolerable mystery, Everett dared to ask, what if the wave function is real? What if every possibility happens? What if the universe is not one, but infinite? The contrast is striking. On one side, the pragmatism of Copenhagen. Stick with what works. Ignore deeper questions. Accept collapse as fact. On the other, Everett's bold realism. Trust the mathematics, no matter how strange its implications. It is a contrast between safety and vision, between modesty and audacity, between closing the box and daring to open it. This tension reflects a deeper theme in science itself. Every breakthrough, from heliocentrism to relativity, has asked us to abandon comfort and embrace strangeness. Many worlds may be the next step in that tradition, a leap that feels absurd today, but may seem inevitable tomorrow. Yet even if it is true, the consequences are almost unimaginable. If every outcome occurs, then every version of you exists. Every decision you did or didn't make, every path you did or didn't take, is realized somewhere. In Everett's universe, nothing is lost. Regret becomes meaningless because in some branch, the opposite choice is alive and unfolding. At the same time, uniqueness itself dissolves. You are not one, but countless. Every joy, every failure, every possibility real, somewhere forever. To some, this vision is liberating, offering infinite second chances. To others, it is terrifying, reducing individuality to a swarm of copies. Either way, it forces us to confront the scale of possibility and the fragility of what we call reality. The story of Hugh Everett is a story of contrasts, genius and obscurity, vision and dismissal, tragedy and rediscovery. It reminds us that the boundaries of science are not only shaped by data, but by imagination, courage, and the willingness to follow equations wherever they lead, even into infinity. And it sets the stage for the next chapter of our journey, because Everett's idea did not die with him. It sparked a debate that still rages today, a debate that pushes us to ask, is many worlds a bold truth or a beautiful illusion? Is it physics or philosophy in disguise? To explore this, we must step into the arena of theory and debate, where interpretations clash, and where the meaning of reality itself hangs in the balance. The idea of parallel universes is intoxicating. It ignites the imagination, promising infinite worlds, infinite lives, infinite versions of ourselves scattered across the cosmic tapestry. But for physicists, the question is not whether the idea is beautiful, it is whether it is true. And here lies the great divide. Some see the many worlds interpretation as the most elegant explanation of quantum mechanics, while others dismiss it as untestable speculation. A philosophy dressed in the garb of science. To understand this debate, we must first look at the landscape of interpretations. For although quantum mechanics works flawlessly as a predictive tool, what it means, what it says about the nature of reality, remains deeply contested. The first great contender is the Copenhagen interpretation. For decades, it reigned as the orthodox view. According to Copenhagen, the wave function is not real but a mathematical description of knowledge. When you make a measurement, the wave function collapses and the particle takes on a definite value. Before observation, reality exists only as probability. After observation, it solidifies into fact. This picture is pragmatic and conservative. It does not demand infinite universes or hidden dimensions. It simply says, stop asking what lies behind the equations, accept probability as fundamental, and focus on prediction. Yet to me, Copenhagen feels unsatisfying. Collapse is not a physical process. It is a rule added by hand. What counts as an observer? A conscious mind? A measuring device? The environment? Copenhagen avoids these questions, but in doing so, it leaves a gap. For skeptics, this gap is less a solution than a refusal to confront the mystery. Then there is the pilot wave theory, also known as the Broglie bomb mechanics. Here, particles always have definite positions, guided by a hidden pilot wave. The wave evolves according to the Schrödinger equation, while the particles trace out precise trajectories. In this picture, quantum weirdness emerges not from probability, but from our ignorance of the hidden variables controlling the motion. Determinism is restored at the cost of introducing non-locality instantaneous connections across space. Einstein, who disliked the randomness of Copenhagen, might have felt some sympathy for this deterministic vision. But for many physicists, the pilot wave approach feels clumsy, adding hidden machinery without necessity. A third family of interpretations proposes something even more radical, that the wave function truly collapses, but through an objective physical process. These are the objective collapse models. Here, superpositions are real, but unstable. Over time, or under certain conditions, they spontaneously collapse into one outcome. In this way, collapse is no longer arbitrary, but built into the fabric of physics. Some even suggest this collapse is tied to gravity, linking the quantum to the cosmic. But no experiment has yet confirmed such mechanisms, leaving the models intriguing but unproven. And then, standing apart from all of these, is Everett's vision. Many worlds. No collapse, no hidden variables, no arbitrary rules. Just the equations, taken literally. Every outcome realized, every possibility branching into a new universe. For its defenders, this is elegance incarnate, no extra postulates, no mysteries swept under the rug. For its critics, it is extravagance beyond measure, a multiplication of worlds without evidence. The tension comes down to a philosophical fault line: testability versus explanatory power. Many worlds explain everything without contradiction. But how do you test it? If the other universes are forever inaccessible, if we can never cross into them or detect their existence, can the theory truly be called science? For some, the answer is no. A theory that cannot be tested belongs to metaphysics, not physics. For others, the testability standard is more subtle. Many worlds, they argue, makes no predictions different from standard quantum mechanics, but it offers a deeper understanding of why mathematics works. Perhaps, they say, this is enough. The debates are fierce. Physicists who support Copenhagen accuse many worlds of being an extravagant fantasy. Supporters of many worlds counter that collapse is nothing more than a convenient fiction. Pilot wave enthusiasts argue that determinism must be restored, while collapse theorists insist that quantum randomness must have a physical mechanism. Each camp accuses the others of missing the point. This clash reveals something profound about the nature of science itself. At its core, science is not only about predicting outcomes, it is about telling a coherent story of reality. But when reality itself refuses to reveal its foundations, the line between science and philosophy blurs. Quantum mechanics, with its uncanny success and its unresolved mysteries, forces us into this liminal space, where equations work perfectly but interpretation remains elusive. Some physicists embrace this uncertainty with humility. They argue that interpretations are like languages, different ways of describing the same mathematics, none more true than the others. What matters, they say, is prediction, not philosophy. But for others, this resignation feels premature. To them, interpretations are not optional metaphors, but clues to the hidden structure of reality. Choosing among them is not just a matter of taste, but a step toward discovering the deeper laws of the cosmos. It is in this crucible of debate that the many worlds interpretation gains its power. Its defenders do not claim it is proven, but they insist it is honest. It does not hide collapse behind a veil of pragmatism. It does not insert hidden variables or ad hoc rules. It simply accepts mathematics as it is, no matter how strange the implications. In doing so, it invites us to expand our imagination, to confront the possibility that reality is not a single line but an infinite tree of branching. Worlds. Critics reply with equal passion. They warn against mistaking imagination for evidence. They argue that elegance is not enough, that science without testability risks becoming a myth. They remind us that the history of physics is littered with beautiful ideas that turned out to be wrong. Many worlds, they say, may be nothing more than a shimmering mirage, captivating but empty. The debate is not merely scientific, it is existential. If many worlds is true, then the universe is unimaginably vast, not only across space, but across possibility. Every choice, every chance event, births another branch, another reality. In such a cosmos, individuality is diluted, destiny fragmented, meaning itself questioned. If Copenhagen is true, then reality is stranger still, a universe where observation creates facts, where probability rules existence, where the act of measurement shapes the world. If pilot wave is true, then the cosmos is deterministic, but at the cost of spooky connections across distance. If objective collapse is true, then the universe carries within it a hidden law, collapsing possibilities into reality in ways we have yet to uncover. Each interpretation carries with it not just a scientific model, but a worldview. Each shapes how we see ourselves, our choices, and our place in the cosmos. And because none has been decisively proven, the debate rages on, with physicists and philosophers locked in a dance between evidence and imagination, between humility and audacity. This is what makes quantum foundations unlike any other field in science. It is not a matter of measuring numbers more precisely, but of confronting mysteries that sit at the edge of what science can even address. It is a battlefield where logic collides with wonder, where the limits of testability clash with the hunger for understanding. In this sense, the debate over many worlds is not a distraction from physics, but its very heart. It reminds us that science is not only about building technologies or predicting outcomes. It is about asking what the universe is and what it means to exist within it, and so we stand at a precipice. On one side, the rigorous demand for testability, insisting that without experiments, theories remain speculation. On the other, the call to follow mathematics, no matter how wild the vision it presents. Between them lies the riddle of reality itself. The question is not only which interpretation is correct, but how we decide what counts as truth. Must truth always be measurable? Or can it also be inferred, glimpsed in the elegance of equations, the coherence of ideas, the refusal to accept contradiction? Whatever the answer, one thing is certain: the debate itself is far from over. And as we turn from this clash of interpretations toward the human dimension, we are left with a haunting thought. If many worlds is true, then each decision you make does not merely shape your life. It shapes the universe itself, spawning realities you will never see, but that nonetheless unfold in parallel. And so our journey now turns inward, from equations and debates to the question of identity itself. What does it mean to live in a world where every choice creates another you? Up until now, our journey has dwelled in the realm of physics, wave functions, experiments, competing interpretations. But what happens when we step out of the laboratory and turn the lens inward onto ourselves? If the many worlds interpretation is true, if every decision splits reality, then what does that say about you? Are you a singular individual, or are you endlessly scattered, replicated across infinite universes? It is one thing to imagine particles branching, photons scattering into countless outcomes, electrons exploring every path. It is another to imagine your own life doing the same. Every choice you make, from the smallest hesitation to the most monumental decision, spawning another you, each one as real as the self you inhabit now. Pause for a moment and let that sink in. In one universe, you chose to wake early. In another, you pressed snooze. In one, you took the risk. In another, you stayed safe. Somewhere, you followed that childhood dream. Somewhere else, you never did. Each branch a life, each life a self, all springing from the same root, but growing in different directions. This vision is both exhilarating and unsettling. On the one hand, it suggests you are never trapped by the road you did not take. Every possibility unfolds, and somewhere, another you is living the life you sometimes long for. On the other hand, it raises a deeply troubling question. If every version of you exists, then what does it mean to be you at all? We tend to think of ourselves as singular beings, continuous thread stretching through time. But many worlds fractures that continuity. Instead of one thread, there are countless, splitting endlessly, each carrying forward a different version of identity. Which one is the real you? The answer may be all of them or none. Philosophy has wrestled with identity for centuries. From the Ship of Theseus to debates on the self in Eastern traditions, thinkers have asked whether identity lies in matter, memory, or consciousness. The multiverse introduces a new twist. Identity not as a singular essence, but as a swarm. A fractal pattern of selves, each branching from the decisions of the moment. Consider free will. In a single universe view, your choices define you. You stand at a crossroads, weigh your options, and the path you take becomes your story. In many worlds, every path is taken. Free will become strange, almost hollow. You choose yes, but every choice spawns another reality where you did the opposite. Your will does not close off possibilities. It multiplies them. Is this empowering or disempowering? Some argue it grants freedom from regret. You need not mourn the road not taken, because somewhere another you took it. Others argue it robs choice of meaning. If every option is realized, then your decisions matter less, not more. You are not steering the ship of your life. You are spawning a fleet of ships, each sailing in every direction. Responsibility becomes equally fraught. If countless versions of you exist, who bears the weight of your actions? In this universe, you chose kindness. In another, cruelty. In this one, you achieved greatness. In another, you failed. Can you still claim moral credit or blame, knowing that infinite copies of you act otherwise? Or does responsibility remain tethered to the self you inhabit now, regardless of the branches beyond your reach? The unsettling thought is that individuality may be an illusion. You may feel singular, but you are also one of many. Like a reflection fractured in a hall of mirrors, each version of you feels real, but none is the original. The original, if it ever existed, is lost in the infinite branching of reality. And yet, there is another way to see it. Perhaps uniqueness lies not in being singular, but in being this version of you, in this universe, in this moment. Yes, there may be countless others, but none will ever live this exact sequence of events. Your perspective, your path, your story, still unrepeatable, still yours. The infinite does not erase the finite. It frames it with cosmic scale. Think of it like stars in the night sky. There are countless suns scattered across galaxies, yet the one you see above you, the one that lights your world, is unique in its relationship to you. Likewise, there may be infinite selves, but the one experiencing this thought, this breath, this heartbeat, is still precious beyond measure. The tension between these two views, the dissolving of individuality, the sanctity of the moment, mirrors the larger tension of many worlds itself. Is the theory a liberation from collapse, or a surrender to extravagance? Is identity shattered or transformed? This question has not escaped philosophers and scientists alike. Some argue that many worlds supports a kind of quantum immortality, the idea that in some branches, you always survive, continuing on in an unbroken thread. Others caution that this is a dangerous illusion, confusing probability with certainty, mistaking possibility for destiny. But whether comforting or disturbing, the very idea forces us to confront mortality, meaning, and the nature of selfhood in ways few scientific theories ever have. Even outside the realm of philosophy, the multiverse idea resonates with the human heart. Who has not wondered what life might have been if different choices had been made? Who has not imagined alternate selves, living out the dreams abandoned or denied? In many worlds, those imaginings are not just fantasies. They are realities, unfolding beyond your reach. But here lies the paradox. You will never meet those other selves. The branches diverge, and once split, They remain forever separate. No window opens between them. No bridge allows crossing. You are trapped in your branch, as are all the other versions of you. The multiverse may be infinite, but your access to it is not. You live one life, see one path, even as countless others bloom unseen. This boundary between what might exist and what you can experience raises a final, haunting question. If infinite versions of you exist, but you can never meet them, does their existence matter? Or is the only identity that matters the one you carry in this single-lived universe? Perhaps the answer depends not on physics, but on perspective. Some will see the multiverse as a grand diminishment, reducing us to interchangeable copies. Others will see it as an elevation, situating our lives within a vast cosmic play of possibility. For some, it is terrifying. For others, it is beautiful. Either way, it changes the way we look at ourselves. No longer singular threads, but branching rivers. No longer lone actors, but fractals of identity spread across infinity. Each decision, both trivial and profound, echoing into countless worlds. And yet, even in that vastness, this truth remains. You are here, now in this branch, in this universe. Whatever else may be true elsewhere, this is the life you inhabit. This is the version of you that can choose love, regret, and hope. And perhaps, in the end, that is enough. Our journey has carried us from the mathematics of particles to the paradoxes of the self. But the story does not stop here. If many worlds challenges our sense of identity, it also invites us to look backward beyond individuals, beyond civilizations, into the echoes of ancient myths and the cosmologies that long ago hinted at parallel realities. Because humanity has wrestled with the idea of multiple worlds, not just through physics, but through story, legend, and imagination. And so we turn now from the splitting self to the multiverse of myth. Long before electrons and wave functions, before laboratories and equations, humanity looked up at the stars and asked the same questions that drive physics today. What is the nature of reality? Is the universe singular and fixed, or layered and infinite? Across cultures and centuries, myths and cosmologies emerged that seem to echo in poetic form. The ideas modern science now struggles to articulate. In the Hindu tradition, the cosmos is not a single creation, but a cycle of births and dissolutions. The universe arises, endures for a vast age, then collapses back into primordial potential, only to be born again. These cycles are unimaginably long, spanning billions of years, far beyond the scale of human history. And within them lies an even more radical vision. Countless universes, each with its own laws, unfolding in parallel. In ancient texts, gods wander between these realms, stepping from one universe into another as if moving between rooms. Here, the idea of a multiverse is not an exotic hypothesis, but a given truth woven into the spiritual fabric of existence. Norse mythology offers a different vision, equally haunting. At its center stands Yggdrasil, the great world tree, whose roots and branches bind together multiple realms. Midgard, the world of humans, is but one among 9 interconnected worlds. Each has its own beings, its own destinies, its own unfolding narratives. The world tree itself becomes a cosmic structure of branching timelines, echoing Everett's vision of a universe that splits and grows with every possibility. Fate weaves through these worlds, but choice and chance still ripple across the branches, shaping the stories that unfold. The Mayan cosmology paints yet another picture, a layered universe, with 13 heavens above and 9 underworlds below, stacked like an invisible architecture around our lived reality. Each layer is populated by deities, forces, and energies, influencing human life in subtle and mysterious ways. To the Mayans, existence was never flat. It was multidimensional, layered, and vast, a universe of levels and crossings. echoing the quantum notion that reality may contain unseen dimensions beyond our perception. These myths differ in detail, but they share a striking resonance. Each imagines reality not as a singular, closed box, but as a branching, cyclical, or layered structure. Each suggests that what we see is only a fragment of a greater whole, a single thread in a cosmic tapestry far too vast for human eyes. It is tempting to dismiss these visions as metaphor, born from imagination rather than evidence. And in one sense, they are. Ancient storytellers did not measure particles or probe the mathematics of wave functions. Their multiverses were woven from symbols, not equations. Yet, in another sense, they were grappling with the same intuition that drives science today, that reality is stranger, deeper, and more expansive than the surface suggests. The contrast is illuminating. Where modern physics builds on experiment, myth builds on imagination. Where science seeks predictive power, myth seeks meaning. And yet, both point to a cosmos that resists singularity, that opens itself to multiplicity and possibility. In myth, gods walk between worlds. In physics, particles explore multiple paths. In myth, time cycles endlessly. In physics, universes may branch infinitely. Different languages, same echoes. Why do such ideas appear across cultures? Perhaps because the human mind, confronted with the mystery of existence, cannot help but imagine beyond the visible. When faced with the vastness of the stars, the fragility of life, the inevitability of death, cultures turn to stories of multiple worlds, cycles, and layers as ways to make sense of what could not otherwise be grasped. Myth became an early attempt to articulate the intuition that reality is larger than it appears. And now, in the age of quantum mechanics, we find ourselves returning to those same intuitions, armed not with poetry, but with mathematics. The many worlds interpretation, with its branching universes, sounds uncannily like Yggdrasil's branches. The layered cosmos of the Mayans resonates with theories of higher dimensions. The Hindu cycles echo cosmology's oscillating models of expansion and collapse. What once was a myth becomes a hypothesis. What once was a metaphor becomes an equation. But there is also danger here. It is easy to conflate metaphor with science, to mistake poetry for proof. The multiverse of myth cannot be tested, just as the many worlds interpretation may never be directly confirmed. Both walk the line between vision and speculation, daring us to imagine but denying us certainty. This tension between ancient imagination and modern science reminds us that human understanding always lives in contrast. We reach for the unknown with whatever tools we have: story, symbol, or equation. Myths gave us one kind of map, physics another. Neither map is complete. Both point beyond the horizon. And perhaps that is the deeper message. The multiverse, whether spoken of in myth or measured in equations, is less about answers and more about perspective. It tells us that reality is larger than our grasp, that our world may be one among countless others, that our lives may be threads in a fabric woven across dimensions. The ancients intuited it. Physics now formalizes it. Between them lies a continuum of human wonder, stretching from campfires to particle accelerators, from sacred stories to Schrodinger's cat. As we carry these echoes forward, we must ask, what do they mean for us today? Myths gave meaning to lives lived under the stars. Physics seeks truth about the cosmos itself. Where these two currents meet, we find ourselves standing at the threshold caught between science and imagination, between evidence and metaphor. And it is here, on that threshold, that we must turn our gaze forward. For if the ancients dreamed of multiple worlds, and if physicists now debate their mathematical reality, what happens when we consider the future? What does it mean for human destiny if the universe is not singular, but infinite? If identity itself is scattered across countless selves? If the cosmos is a multiverse, where every choice, every possibility, every reality unfolds? The myths remind us that humanity has always asked these questions. Physics reminds us that they are not yet answered. Together, they invite us to take the next step, to imagine what the multiverse might mean not just for gods or particles, but for the future of civilization itself. At the heart of quantum mechanics lies a puzzle so profound that it reaches beyond physics into philosophy, psychology, and even spirituality. The puzzle is this: what role does the observer play in shaping reality? In classical science, observation was passive. A planet circles the sun, a stone falls to the ground, a chemical reacts with another. Whether or not anyone is watching, the universe unfolds according to its laws. But quantum mechanics unsettles that picture. In the microscopic realm, the act of measurement doesn't simply reveal reality. It seems to participate in creating it. Consider Schrodinger's cat, perhaps the most famous thought experiment in physics. A cat is placed in a sealed box with a quantum mechanism, a radioactive atom that may or may not decay, a detector that may or may not trigger poison. According to quantum rules, until the box is opened, the atom exists in a superposition of decayed and undecayed. And because the atom's fate is tied to the cat itself is suspended in a bizarre limbo, both alive and dead. Only when the observer opens the box does the wave function collapse, resolving the ambiguity into one outcome. The image is absurd. A half-dead, half-alive cat, but the absurdity points to a deeper mystery. Does reality exist in multiple states until it is observed? Does consciousness itself force the universe to decide? This question becomes even stranger in the Wigner's friend scenario. Imagine an observer inside a lab who performs a quantum measurement. From their perspective, the outcome is definite. They see a result. But to an outside observer who has not yet looked inside, the entire lab, including the friend and their memory, remains in superposition. In other words, reality can be both definite and indefinite, depending on whose perspective is considered. The observer becomes part of the experiment. Consciousness itself becomes entangled in the mystery. Such paradoxes raise unsettling questions. If observation collapses possibilities into reality, then what is the nature of the observer? Is consciousness merely a byproduct of brain activity, or is it a fundamental ingredient of the cosmos, woven into its very fabric? Materialist science tends to resist such ideas. From this view, consciousness arises from complex arrangements of matter. Neurons fire, synapses connect, and somewhere in the patterns of activity, awareness emerges. The brain is not a participant in reality's unfolding. It is a machine that registers the outcomes of physical laws. Observation doesn't collapse wave functions. Physical interactions do, regardless of whether a conscious mind is involved. Yet others see in quantum mechanics a profound clue that consciousness cannot be reduced so easily. If the act of observation really matters, then perhaps the mind is not just an emergent property, but something deeper. Some propose panpsychism, the idea that consciousness pervades all matter, that every particle contains a spark of experience. Others suggest that consciousness is not just part of the universe, but the ground of being itself, the canvas upon which reality is painted. These perspectives find resonance in both science and philosophy. Eugene Wigner himself, a Nobel laureate, speculated that consciousness might be fundamental to quantum measurement. Later, physicist John von Neumann argued that the collapse of the wave function could only be completed in the mind of the observer. Such views blurred the line between physics and metaphysics, leaving many uncomfortable. And yet, even as mainstream science resists, the question refuses to go away. Recent experiments push the paradox further. Physicists have tested versions of the Wigner's friend scenario and found results that suggest objective reality may not exist in the way we once thought. Outcomes may depend on the observer's perspective in ways that defy classical logic. The implication is startling. Reality might not be a fixed stage upon which consciousness acts, but a participatory process in which consciousness plays a role. Still, skepticism abounds. Critics argue that invoking consciousness to solve quantum mysteries replaces one puzzle with another. We don't understand how the brain generates awareness, so how can we claim that awareness shapes the universe? Better, they argue, to seek explanations in physics alone. Decoherence, hidden variables, objective collapse models. Keep consciousness in the realm of biology and psychology, not cosmology. Yet for others, the resistance feels like denial. Consciousness is the one thing we cannot doubt. Our own awareness is more certain than any particle or equation. To relegate it to a byproduct seems unsatisfying. Perhaps quantum mechanics, with its stubborn insistence on the role of observation, is pointing us toward a deeper truth, that mind and matter are not separate, but intertwined at the most fundamental level. This tension between materialist reduction and consciousness as fundamental defines one of the most profound debates in science and philosophy today. On one side, the comfort of physics as usual, where measurement problems will eventually yield to mathematics and experiment. On the other hand, the daring intuition that consciousness itself may be the key to unlocking reality. Evidence versus mystery, skepticism versus wonder, reduction versus expansion. And beyond this debate lies an even greater question. If consciousness does play a role in shaping reality, then what is the scope of its power? Does each observer collapse their own branch of the wave function? Do multiple minds co-create a shared universe? Could the collective consciousness of humanity, or of all beings, be entangled with the unfolding of the cosmos itself? Here, physics begins to blur into philosophy, and philosophy into something more like mysticism. Traditions around the world have long spoken of cosmic consciousness, the idea that mind is not confined to individuals, but is a universal field, a shared fabric in which all beings participate. From the Brahman of Hindu philosophy to the Tao of Chinese thought, from mystical Christianity to indigenous cosmologies, cultures have intuited that awareness is not local but cosmic. Quantum paradoxes, to some, seem like a scientific echo of these ancient insights. Yet science demands caution. To leap from paradox to mysticism is tempting but dangerous. The equations do not say that consciousness creates reality in a mystical sense. They only say that measurement plays a role, and the interpretation of that role remains unsettled. Still, the resonance is undeniable. When physics and philosophy whisper the same mystery, we are compelled to listen. This is the cinematic power of the observer problem. It places us not outside the universe as detached spectators, but within it as participants. We are not merely watching the play, we are part of the script, perhaps even co-authors of its unfolding. And this raises one final, haunting possibility. If consciousness is entangled with the universe, then exploring the multiverse is not just about physics. It is also about the mind. The branching of worlds may not only describe particles and planets, it may describe selves, choices, and awareness itself. In this view, the boundary between quantum mechanics and human existence dissolves. The cosmos becomes not just matter, but experience. Not just a multiverse, but a multi-mind. Such ideas may unsettle, but they also inspire. They remind us that the mystery of reality is not out there in distant galaxies alone. It is here, in the immediacy of perception, in the simple fact that you are aware. The universe may be infinite, branching, and strange, but your consciousness is the gateway through which it appears. From Schrodinger's cat to Wigner's friend, from equations to introspection, the observer problem shows us that the story of the multiverse is also the story of mind. And as we move forward, we must ask, if consciousness plays a role in shaping reality, What does that mean for the future of science and for the destiny of humanity itself? Because the next frontier may not be outer space or inner particles, but the intersection of mind and cosmos, the place where physics and consciousness meet, and where the true shape of reality waits to be revealed. The multiverse is not only about particles and wave functions. If every quantum event creates a branching universe, then evolution itself, life's long unfolding, must also branch endlessly. Each mutation, each environmental shift, each twist of chance in the story of Earth would ripple outward, creating worlds where history followed entirely different paths that begin with the age of the dinosaurs. In our timeline, 66 million years ago, an asteroid struck Earth, triggering mass extinction. The great reptiles vanished, mammals rose, and eventually humans appeared. But in another branch, perhaps the asteroid missed. Dinosaurs endured, evolving intelligence of their own. Imagine cities of scaled architects, philosophies written in clawed script, civilizations beneath reptilian suns. In that universe, humans might never have existed at all, or take the evolution of hominins. In our world, Homo sapiens emerged as the dominant species, while Neanderthals and Denisovans faded into memory. But in other branches, Neanderthals may have triumphed, building their own civilizations. In others still, multiple human species coexist, sharing the planet as rivals or collaborators. Alternate humanities with different minds, different cultures, different destinies. The same branching applies to history itself. The rise and fall of civilizations hinges on countless moments of chance battles won or lost, leaders rising or falling, inventions spreading or withering. Each event a fork in time, each fork birthing a new world. Consider Rome. In our timeline, the empire crumbled, leaving ruins and legacies that shaped Europe and beyond. But in another branch, Rome never fell. Its legions still march, its senate still debates, its empire still stretches across continents. Imagine technologies advanced under Roman discipline, philosophies evolving under Roman governance, space exploration fueled by imperial ambition. A Roman star empire, carried forward by the momentum of history unbroken. Or imagine if the libraries of Alexandria had not burned. In our world, untold knowledge was lost. Texts of science, philosophy, and history gone forever. But in another timeline, the library survived. Human progress accelerated centuries ahead. Perhaps electricity was harnessed in antiquity. Perhaps machines powered by steam or even digital logic appeared long before our era. The Industrial Revolution might have arrived in the time of Caesar. The Internet might have bloomed before the Middle Ages. Entire futures, accelerated by wisdom, preserved rather than lost. Myth itself may be echoes of these alternate branches. Legends of Atlantis, a civilization advanced yet vanished, could be whispers of worlds where it endured, thriving in ways ours did not. Norse tales of Ragnarok, Mayan calendars of world cycles, Hindu yugas of creation and destruction. Each may reflect an intuition that history itself branches, repeating and diverging across infinite timelines. But here we must pause. These visions are intoxicating. Dinosaurs building cities, Neanderthal civilizations, Roman empires that never fell. Yet we must ask, are these scientific possibilities or speculative dreams? From a scientific standpoint, the many worlds interpretation suggests that every quantum event does create branches. But whether those branches truly lead to worlds where Rome rules the stars or Neanderthals build cities depends on how probability cascades across evolution and history. Mathematics does not describe dinosaurs with technology. It describes probabilities of particles. From those probabilities, imagination takes flight. And yet, that flight is not meaningless. For it reveals how deeply the multiverse idea touches the human imagination. It does not only reframe physics, It reframes our sense of history, destiny, and identity. In the multiverse, what did not happen here may still happen elsewhere. Our losses, whether species gone extinct, knowledge lost, civilizations fallen, are not absolute. They are preserved in some other branch, still unfolding, still alive. This thought is comforting, but also haunting. Comforting because it suggests nothing is ever truly lost. Haunting because it reduces the uniqueness of our history. Is the rise of humanity special if infinite other humanities exist? Is the fall of civilizations tragic if countless versions of them endure elsewhere? Once again, the multiverse both expands and diminishes, liberates and unsettles. For historians and philosophers, the implications are profound. If all possibilities occur, then history as we know it is not destiny, but accident one path among infinite others. Our textbooks become chronicles of a single branch, while the true history of humanity sprawls across countless timelines. The great what-ifs of history. What if Alexander had lived longer? What if the Black Death had never struck? What if the Cold War had gone hot? Are not mere speculation, but realities somewhere in the multiverse. And yet, we remain bound to our own branch. We cannot step into the Rome that still stands, nor walk the streets of Neanderthal cities, nor visit a world where the stars are ruled by reptilian philosophers. We can imagine them, but never reach them. The barrier is absolute. For us, history remains what it is, a singular sequence of events. No matter how many alternatives exist beyond our grasp. This tension between what did happen and what might have been creates a poignant duality. The multiverse assures us of infinite variety, yet we live only one thread. Our lives, our civilizations, our choices matter not because they are unique across all reality, but because they are ours in this reality. In the face of infinity, the finite becomes even more precious. And so we arrive at a new perspective. The multiverse does not diminish history, it reframes it. It shows us that what we call history is a fragile, contingent path, one of countless that could have unfolded. It reminds us of the weight of chance, the power of decisions, the fragility of civilizations. And it invites us to imagine, what if we could see those other branches, not as unreachable fictions, but as mirrors that reveal the possibilities within our own? From evolution to empire, from myth to speculation, the multiverse casts history in a new light. And as we step forward, we must ask, if history branches endlessly, what does that mean for the future? If civilizations diverge across infinite timelines, then where is our own path headed? Will our branch endure, collapse, or transcend? The answers lie not in the past, but in the horizon ahead, the future of civilization in a multiverse of possibilities. The elegance of the many worlds. Interpretation lies in its simplicity. Every quantum possibility happens. No wave function ever collapses. No option is ever lost. But elegance alone is not enough. Science lives and dies on one question. Can it be tested? Can an idea, however beautiful, step beyond philosophy into the crucible of experiment? This is where the many worlds interpretation faces its greatest challenge. For how can we ever measure another universe if by definition it is forever separated from our own? If we cannot observe these parallel branches, then are we not building castles of imagination upon foundations of air? And yet, scientists do not abandon the question. They ask instead, if the worlds cannot be touched directly, might their shadows be glimpsed indirectly? Could the mathematics of quantum mechanics, when stretched to its limits, leave fingerprints of other universes upon our own? One possible window comes from quantum computing. At its core, quantum computing depends on superposition, the ability of a particle to exist in many states at once. When a quantum computer solves a problem, It explores an astronomically large number of possibilities simultaneously. Some physicists have speculated that this is, in essence, computation across parallel worlds, with each branch of the multiverse carrying part of the calculation. If this interpretation is true, then every answer produced by a quantum computer is a chorus of many universes speaking together. But here, too, the debate begins. To many scientists, invoking parallel worlds is unnecessary. Quantum computers can be explained entirely within our universe, using probability and interference. No need to multiply realities. Yet the suspicion lingers when we harness quantum mechanics on such a scale. Are we brushing against the fabric of the multiverse itself? Decoherence theory offers another path. In the standard Copenhagen view, observation causes the collapse of the wave function, leaving only one outcome. But in many worlds, collapse never happens. Instead, decoherence explains why quantum superpositions vanish into classical reality. The environment itself measures the system, splitting worlds silently, invisibly. When an electron passes through both slits of an experiment, the interference pattern remains until stray photons or molecules interact with it, forcing the quantum wave into branches we cannot perceive. Decoherence is testable. Physicists have built increasingly delicate experiments, isolating quantum systems from their environment, prolonging their superpositions. Each success supports the mechanism. And yet, decoherence itself does not prove many worlds. It explains why the world looks classical, but not whether all branches exist. Once again, we face the divide. Science gives us tools to describe phenomena, but the interpretation, whether collapse occurs or universes, branch remains beyond the reach of direct confirmation. This tension extends to speculative physics beyond the standard model. Some theorists ask, could cosmology provide evidence of branching universes? In the early universe, quantum fluctuations seeded galaxies and stars. If many worlds is true, then every possible fluctuation occurred somewhere. Our cosmos, then, is but one variation in eternal branching froth. But how could we ever prove it? Cosmic microwave background maps offer hints of strangeness, statistical anomalies, unexplained cold spots, but they fall far short of confirmation. To call them evidence of the multiverse is to leap from science into story. Others turn to black holes. If information is preserved in branching universes, perhaps the paradoxes of black hole evaporation could be resolved. Still others speculate about exotic particles or hidden dimensions, relics of branching beyond our perception. Each proposal sparks debate, yet none can cross the threshold from speculation into definitive proof. And so we confront the haunting possibility that many worlds may forever remain untestable. If each branch is sealed away, if no experiment can reach across the divide, then what we call a scientific theory might instead be philosophy wearing the mask of physics. This does not mean it is false, only that it is unfalsifiable, immune to the judgment of experiment. And in science, unfalsifiable ideas sit uneasily, however captivating. Yet perhaps this is where the true mystery lies. Physics itself rests upon interpretation. Quantum mechanics works with astonishing precision. Its predictions match experiments to extraordinary accuracy. But what those equations mean, what reality they describe, remains uncertain. Copenhagen says, collapse is real. Many worlds says, collapse never happens. Pilot wave theory says, hidden variables guide the quantum. Objective collapse says, the universe itself prunes possibilities. Each fits the mathematics. Each predicts the same results. Each paints a different picture of reality. In this way, the multiverse debate exposes the limits of science. Physics can tell us how particles behave. But when it comes to what reality truly is, the answers may forever slip beyond measurement. we may be left with philosophy, metaphysics, and imagination, filling the gaps where equations cannot tread. This realization is both humbling and inspiring. Humbling, because it reminds us that human knowledge has boundaries. Inspiring, because it shows us that science and philosophy are not enemies, but partners. Where experiments end, wonder begins. Where data falls silent, imagination takes its place. Still, the pursuit continues. Physicists push experiments to greater delicacy, greater precision, probing the edge of reality. Quantum computers grow more powerful. Decoherence is studied with increasing rigor. Cosmology maps the earliest light of the universe. Each advance brings us closer to the question, even if the answer remains hidden. And perhaps the answer need not be final. The value of many worlds may not lie in its proof, but in its perspective. It invites us to see reality not as a single thread, but as a branching tapestry. It challenges us to think beyond what we can measure, to confront the possibility that existence is richer, stranger, and more abundant than we can ever observe. The haunting problem remains. Is many-world science or philosophy masquerading as physics? The truth may be that it is both. A scientific framework with philosophical weight. A theory that cannot be proved, yet cannot be dismissed. A mirror that reflects not only the structure of reality, but the limits of human inquiry itself. From this edge, we transition naturally to the future, not only of physics, but of us. If the multiverse is real, what does it mean for civilization? For our survival, our exploration, our destiny? The next step lies not only in laboratories, but in imagination, as we project ourselves into futures across infinite branches. The multiverse is no longer confined to the halls of physics, departments, or the pages of scientific journals. It is spilled outward, saturating the imagination of our culture. Today, when we hear the word multiverse, many of us do not think first of Hugh Everett or Schrodinger's equations. We think of films, television, novels, comics, universes of universes where heroes meet their alternate selves, where destinies fracture and collide, where possibility itself becomes a playground. Hollywood has embraced it with fervor. Superhero franchises weave intricate webs of alternate timelines, introducing audiences to darker doubles, lost futures, and second chances. In one world, a hero dies. In another, they endure. In yet another, they betray. Each thread is spun into a story, offering the thrill of infinite variation. Science fiction, too, has long reveled in the idea. Alternate Earths where the Axis powers won the war, or worlds where technology leapt centuries ahead. Literature bends the multiverse into parable, asking what if, always what if. But why does this idea grip us so powerfully? The answer lies not just in spectacle, but in psychology. The multiverse speaks to a deep human longing, the desire for more lives than the single one we are given. It whispers of regrets undone, choices reversed, second chances taken. In our daily lives, we are bound by the arrow of time, locked into the outcomes of our decisions. Yet the multiverse promises liberation. In some branches, we did not walk away from love. In some branches, we pursued that dream. In some branches, the tragedy never happened. To imagine the multiverse is to imagine redemption. There is also wonder pure and unbridled. The multiverse stretches imagination to its breaking point. It invites us to think not just of Earths and histories, but of entire infinities, worlds where physics itself differs, where stars are woven of matter unknown, where consciousness takes forms beyond our comprehension. It is a canvas vast enough for myth, fantasy, and philosophy alike dot, and so we find echoes of the multiverse in spiritual movements as well. Some traditions speak of countless planes of existence, layers of reality stacked like unseen pages. Others describe reincarnation across worlds, each life a different path of growth. In these teachings, the multiverse becomes not just physics but destiny, a cosmic stage for the evolution of the soul. Whether framed as spiritual ascent or quantum branching, the theme remains the same. Life is larger than a single thread. Yet here we encounter a necessary contrast. Science demands rigor, evidence, and testability. Pop culture demands only resonance. The multiverse in physics is a framework of mathematics, born from equations and debated in seminars. The multiverse in cinema is a stage for adventure and catharsis, unbound by the discipline of proof. The two often collide, their meanings overlapping, their boundaries blurred. Audiences leave theaters with visions of infinite worlds, yet those visions are stories, not experiments. This does not make them trivial. Stories are how humans process reality. They are the way we approach mysteries too vast to solve, the way we clothe abstractions in flesh and motion. When physics hands us the possibility of many worlds, culture translates it into myths for our age. These myths, like the myths of ancient times, give form to our longings, fears, and hopes. They let us feel what equations alone cannot. And here lies the truth. Whether or not the multiverse exists, it already exists in us. It is alive in the stories we tell, the fantasies we dream, the yearning we feel for second chances and infinite horizons. It is both a reflection of scientific speculation and a mirror of human desire. But even as we immerse ourselves in these cultural multiverses, we must return to the question of science. For the actual many worlds interpretation is not a theater of infinite heroes and villains. It is a stark, austere claim about the nature of reality. It does not promise second chances we can live, only that every chance is taken somewhere unseen by us. It does not comfort us with the possibility of meeting another self. It assures us that countless selves exist, but forever separated. Pop culture multiverses offer drama and reunion. The physics of many worlds offers silence and separation. The contrast could not be sharper. The warm embrace of entertainment versus the cold rigor of science. Yet between them, we glimpse the full power of the multiverse idea. It is not only about what reality is, but about how humans experience reality. Science seeks truth. Culture seeks meaning. The multiverse bridges them both. And perhaps this is why it endures. Because whether in physics or in film, in myth or in mathematics, it touches something elemental within us, the yearning for infinity. To imagine other worlds is to admit that this one world, however precious, may not be enough. To imagine other versions of ourselves is to confront the fragility of identity and the boundless hunger of the human spirit. As we leave the silver screens and comic pages, we are left with a question. What does this cultural fascination reveal about us? Why are we drawn again and again to infinite possibilities, even when science cannot confirm them? Perhaps because in the end, we are creatures of wonder. We are not content with a single path. We dream of many. And from these dreams, we turn once more to philosophy. If culture shows us our longing for the multiverse, and science shows us its possible mathematics, then what lies at the intersection? What does the multiverse mean for meaning itself, for responsibility, freedom, and the shape of human existence? That is where we now journey, into the closing chapters, where science meets philosophy and speculation becomes reflection. The idea of the multiverse begins as physics. It grows into speculation. It flourishes in culture. But ultimately, it confronts us with something deeper than science or storytelling, the meaning of existence itself. For if every decision creates a branching universe, if infinite versions of you live out every possibility, then what does this life, this thread, here and now, actually mean? At first glance, the conclusion seems devastating. If there are infinite versions of you, then none are unique. Every triumph you achieve, some other you has failed. Every failure you endure, some other you has succeeded. Every choice you make, some other you has chosen differently. In such a cosmos, individuality dissolves, and with it, perhaps, significance. The multiverse whispers of nihilism, that nothing matters, because everything happens somewhere. This is the dark interpretation, and it cannot be ignored. Philosophers have long warned of the abyss that opens when human uniqueness is denied. If we are but one among infinite variations, why struggle? Why hope? Why care? The existentialists of the 20th century, Camus, Sartre, grappled with similar despair, though in a universe not yet branching. They concluded that meaning must be made, not given. That even in an absurd cosmos, choice creates significance. From this view, the multiverse becomes not the end of meaning, but its raw material. Yes, infinite versions of you exist, but only one is here, in this body, on this earth, at this time. Your choices matter because they are yours, because they shape this thread. You cannot live in the other branches. You can live only this one. That limitation is not weakness, it is the source of meaning itself. Eastern traditions offer another perspective. Buddhism teaches the impermanence of the self, the illusion of individuality, the endless cycles of rebirth. To a Buddhist, the idea of infinite versions of oneself is not alien, but familiar. The self is never singular, never permanent. What matters is not clinging to uniqueness, but cultivating awareness and compassion across all existence. In this frame, the multiverse is not nihilism, but liberation. If countless versions of you exist, then suffering and joy are equally endless, and so the call to compassion becomes infinite. Other philosophies push further still. Some strands of Hindu cosmology imagine endless cycles of creation and destruction, universes without beginning or end. In that vision, the self is but a ripple in an infinite ocean of being. The multiverse echoes this. Our lives are waves upon waves, branching endlessly. Meaning, then, is not found in permanence, but in participation, being part of the vast cosmic dance. These perspectives contrast sharply. The existentialist cry for personal creation of meaning, the Buddhist call to transcend individuality, the Hindu vision of cosmic cycles. Yet all converge on a similar point. The multiverse does not erase meaning. It transforms it. The challenge lies in choice. In a single universe worldview, your choices define your destiny absolutely. In a multiverse, your choices define only this branch, while other versions of you live other fates. Does that diminish your responsibility? Or does it magnify it, reminding you that even in infinity, you must still live your path with integrity? Here we encounter the paradox of empowerment. The multiverse could inspire fatalism. Why try when somewhere you have already succeeded? But it can also inspire urgency, because in this branch, only you can act, only you can choose, only you can live this life. The existence of other worlds does not erase this one. It underscores it. Consider regret. In our ordinary view, regret weighs heavily because lost possibilities are gone forever. In a multiverse view, regret softens. In some branches, you did take that chance. You did say yes. You did walk the road not taken. But that knowledge can either comfort or torment. Comfort, because no possibility is lost. Torment, because you will never see those other lives. The multiverse becomes a mirror for our longing, reflecting both solace and sorrow. And what of responsibility? If every version of you exists, are you absolved of blame? Or is every branch equally accountable? Here, philosophy diverges. One view says responsibility applies only to the self you are now. Another says responsibility extends across all possible selves, a cosmic moral weight. Imagine the staggering implications. Ethics not for one life, but for infinite lives. The existential crossroads, then, is clear. Nihilism whispers that nothing matters. Empowerment answers that everything matters more than ever. Each branch is infinite, but you are here, now, alive in this one. This moment, this choice, this life is both ordinary and extraordinary. Ordinary because it is one among countless. Extraordinary because it is yours alone to live. The multiverse does not hand us meaning. It demands that we forge it. In that sense, it is no different from the absurd cosmos of Camus or the endless cycles of Eastern thought. It is a canvas vast beyond comprehension, but the brush remains in our hands. And perhaps this is the ultimate lesson. The multiverse invites humility. We are not singular, not central, not unique. Yet it also invites awe. We are participants in a cosmos of infinite possibility. To live fully here, in this branch, is to honor the vastness beyond dawn, so we stand at the crossroads. One path leads to despair. Nothing matters, for all things happen. The other leads to empowerment. Everything matters, for this path is ours. Between them lies the decision each of us must make. Not in some other universe, but in this one, here and now dot, and as we step toward the conclusion, we carry this paradox with us. The multiverse may be infinite, but our time is finite. And perhaps, in that tension, we find meaning not in escaping into other worlds, but in embracing this one. We return, at last, to the moment where we began, the simple act of choice. A hand reaching for a coffee cup. A glance down a street. A whispered yes or no. At first glance, these moments seem insignificant, dissolving into the blur of daily life. But now, after our long journey through physics, philosophy, myth, and imagination, we see them differently. Every decision is no longer just a personal act, it is a ripple across reality, perhaps a fracture in the cosmos itself. If the many worlds interpretation is true, then every choice you make spawns new universes. Every hesitation, every step, every chance taken or refused branches existence itself. Somewhere, you turned left instead of right. Somewhere, you spoke instead of staying silent. Somewhere, you never watched this film, never heard these words, never wondered about these mysteries. Every path lives, every possibility breathes. And yet, the mystery deepens, because we do not know if this vision is reality or imagination. We do not know if a universe truly splits, or if the wave function collapses, or if hidden variables guide the unseen. We live not in certainty, but in wonder. Science gives us equations, but not answers. Philosophy gives us questions, but not closure. And perhaps that is the point. For whether the multiverse exists or not, choice remains real. The act of choosing gives weight to existence. The moment of decision is the crucible of meaning. Even if other worlds branch away, you live only this one. You breathe only this breath. You stand only in this branch of time. And that makes it precious beyond measure. Think of the existentialists who saw life as absurd and meaning as fragile. To them, the multiverse would not erase significance, it would sharpen it. For even in infinity, this thread is yours alone. Think of the Buddhists who saw the self as impermanent and reality as layered. To them, the multiverse would not be strange, it would be liberation, a vastness already intuited. Think of the scientists who trace equations into the fabric of the cosmos. To them, the multiverse is a hypothesis, a possibility, a challenge to test the untestable. Each perspective converges on the same truth. The multiverse, whether real or imagined, transforms how we see ourselves. It humbles us, reminding us that we are not the center of existence. It empowers us, reminding us that our choices still matter deeply. It unsettles us, confronting us with infinite versions of ourselves. And it inspires us, opening the horizon of possibility beyond measure. So what does it mean, here, at the end of our journey? It means that wonder remains. That mystery endures. That science, philosophy, and myth all circle the same eternal fire, the question of what it means to exist. The multiverse is one answer, but it is also a mirror. It reflects not only the cosmos, but the human longing to understand it. Perhaps that is the true gift of the multiverse. Not that it gives us certainty, but that it reminds us of our capacity for awe. That even in the face of infinity, we can still pause, still marvel, still ask, what if? What if the universe branches? What if choices echo across eternity? What if, in the act of living, we are shaping not only our destiny, but the destiny of countless worlds unseen? The closing paradox is simple yet profound. Whether many worlds is true or not, the effect on us is the same. It calls us to live with greater awareness, greater courage, greater wonder. If the multiverse is real, then every choice is cosmic. If it is not, then every choice is still precious, because it is fleeting, unrepeatable, final. Either way, meaning endures. And so, as the camera of imagination pulls back, from the individual to the cosmos, we are left with an image. A single human being, standing at the crossroads of possibility, holding the power of choice. Around them, infinite universes bloom like galaxies. Within them, the same question rises, again and again. Who will you be in this thread of reality? This is not a scientific question. It is not a philosophical puzzle. It is the essence of life itself. To choose, to act, to exist, and in that act, to create meaning. We close then, not with answers, but with invitation. An invitation to wonder, an invitation to reflect, an invitation to live more fully, knowing that even the smallest decision carries weight, whether across universes or simply within the heart. The multiverse may or may not be real, but wonder is real. The mystery is real. And choice, the act of shaping your life, moment by moment, is as real as anything we will ever know. So let us return one final time to the coffee cup, the street corner, the whispered yes or no. These are not trivialities. They are the fabric of existence. They are the choices that echo through eternity, whether in infinite universes or in the singular, fleeting span of this one life. The mystery remains, but so does human wonder, and that, perhaps, is enough.